Hello and welcome to the BS Academy. In the third subject of the GATE Mechanical 2021, which is machine design, this is the third chart of the machine design, which is final chart of this subject. In this chart, we'll include the various topics like first one is design of brakes, then after design of clutch, then after design of bearings. Now let's begin with the first one, which is the design of brakes. As you can see here, first one is block or shoe brake. For that, the equation of P will be like P is equal to N into A plus mu C upon B. Then for counterclockwise rotation, P is equal to N into A minus mu C upon B. Then after self-energizing brake, in that load is applied to the downward direction when the moments of the external braking load P and the frictional force in the same direction about the hinge, then the self-energizing brake will be produced. Then after self-locking brake, P less than or equal to 0 and A less than or equal to mu C. In that condition, self-locking brake will be generated. In the self-locking brake, no external force is required for braking, and self-locking for brake is not desirable, and for clutch also not desirable, but in the screw jack the self-locking is desirable. Then after increase in the intensity of self-energizing brake, chance of self-locking brake increasing more. Then after for bend brake, there are too many equations are there. T1 by T2 is equal to E raised to mu theta, and braking torque is equal to T1 minus T2 into R, as well as line pressure is equal to T tight upon B into R. Here note that in the self-locking in differential bend brake, B less than or equal to E raised to mu theta into A for clockwise rotation, and A greater than or equal to E raised to mu theta into B for the counterclockwise direction. And for simple bend brake, P is equal to A by B into T2 and P is equal to A by B into T1 for counterclockwise rotation. Then after differential bend brake, for that P is equal to T2 by C into B minus T1 by T2 into A, and P is equal to T2 by C into B minus E raised to mu theta into A. Examples are it is used in the lifts, elevators and conveyors, etc. Examples for the bend brake, because by the examples you can understand these questions very easily. Then there is a note there for tight side and slack side. For the pulley, which is driver, the side of belt which is pulled is tight side, and for the belt which is driven, then side of the belt which will try to create a motion is the tight side. This is very simple, but the important point is there. Now coming towards the design of clutch, there are four types of clutch is there. First one is the jaw clutch, then the plate clutch, then the cone clutch, and fourth one is centrifugal clutch. Here remember that the clutch permits engine to start without the external load, and clutch connects or disconnects the input and output shafts at the will of the operator. Then generally clutches are of two types. First one is of positive type clutch, which is jaw clutch or claw clutch, and second one is friction clutch, which is plate clutch. Now the first one is positive clutch, or you can say that jaw clutch or the claw clutch, and it is used for the high speed disengagement, and jaw clutch is mostly important for the engagement and disengagement in the situation like low speed and the high speed. Then no heat generation because of no friction and no slipping. Here engagement force is normal to the jaw of the clutch. Then after the second one is the friction clutch, or you can say that the plate clutch. For this clutch, PA is equal to PN, so P engagement is equal to PS, but PA is not equal to P engagement. And here in this type of clutch, engagement force will be axial to the clutch, then Pn is equal to P into 2 pi r into dr, and T is equal to N into mu into r into Pn. Then R1 is equal to R2 by root 3 for the maximum torque, and there are two main terms are there. First one is for new clutch uniform pressure, and second one is for old clutch uniform wear. So the equation for both the terms will be very useful in the examination. Now for the first one, now for the new clutch uniform pressure condition, Pn is equal to P into pi into R2 square minus R1 square, and T is equal to N into 2 pi into mu into R2 cube minus R1 cube into P by 3. Then the T is equal to 2 by 3 into N into mu P pi into R2 cube minus R1 cube. So you can rearrange that. Then after T is equal to N into 2 by 3 into mu into Pn into R2 cube minus R1 cube upon R2 square minus R1 square. Then the third equation is Rf is for the friction radius. So Rf is equal to 2 by 3 into R2 cube minus R1 cube upon R2 square minus R1 square. Now for the old clutch, Pn is equal to 2 pi into P into R into R2 minus R1, and T is equal to N into pi into mu into P into R into R2 square minus R1 square. Then T is equal to N into mu into Pn into R1 plus R2 by 2, and Rf for the uniform wear type, Rf is equal to R1 plus R2 by 2. Then T is equal to 2 by 3 into mu into Pn into N into R2 cube minus R1 cube upon R2 square minus R1 square. Now there is a note there. The wear theory is the more safe theory as well as the more conservative theory. So if no theory is mentioned in the examination, use the wear theory. And the other note is there, Rf is proportional to T. Then Rf for uniform pressure is greater than Rf for uniform wear, as well as torque for uniform pressure is greater than torque for uniform wear theory. Then after cone clutch, for that sin alpha is equal to R2 minus R1 upon beta, and 2 alpha is equal to cone angle. Then alpha is equal to semi cone angle or pitch angle. Then beta is equal to width of the friction pad, and beta is equal to R2 minus R1 upon sin alpha. Then P engineering is equal to Pn sin alpha plus mu into Pn cos alpha. Pn into sin alpha is equal to Pa, and sin alpha is equal to Pa upon Pn. Then sin alpha is equal to R2 minus R1 upon beta. Then for the uniform pressure theory in the cone clutch, Pn is equal to 2 pi Rd into R into P upon sin alpha. Then T is equal to 2 by 3 into mu into Pn into R2 cube minus R1 cube upon R2 square minus R1 square. Then for uniform wear, Pn is equal to 2 pi P into R into R2 minus R1. Then T is equal to mu into Pa upon 2 into sin alpha into R2 plus R1. Then T is equal to mu Pn upon 2 into R2 plus R1. Then T is equal to mu Pn by 2 into R2 plus R1, and T is equal to 2 by 3 into mu P into pi upon sin alpha into R2 cube minus R1 cube. Then after T cone by T single plate is equal to 1 by sin alpha, then T is proportional to 1 upon sin alpha, and alpha is decreased, then sin alpha is decreased, then T will increase. So by decreasing the torque carrying capacity, T increase, but we can reduce the alpha up to 5 only, because alpha should always greater than or equal to 5 for self disengagement clutch. Then centrifugal clutch, it is used for the low starting torque, and the K is more, speed is more, and force is more. Then omega 2 is greater than omega 1. PS is equal to Fc is equal to mRg into omega 1 square. Then Fc is equal to mRg omega 2 square. Then T is equal to beta into m into mu into r g into omega 2 square minus omega 1 square into Rd, and beta is equal to m into Rg into omega 2 square minus omega 1 square upon P into Rd into theta. Here the engagement will be in the radial direction. Note that from the single plate clutch, the mainly questions were asked in the examination. The other two types were just for your information, but do not skip this portion also. Now coming towards the design of bearings, which is the last point of the subject. Now in that, first one is HSB and the second one is HDB. Here HSB stands for hydrostatic bearing and HDB, as you all know, hydrodynamic bearing. Hydrostatic bearing, in this, high pressurized oil is inputted inside the bearing by the pump, and externally pressurized bearing, then no starting or ending friction in the HSB, then load carrying capacity is independent of the shaft speed, and the advantages like good radial stiffness. Then disadvantages is more space required for this bearing and applications in the turbo generators. Now for the HDB, or you can say that the hydrodynamic bearing, P is generated because of the rotation of shaft inside the bearing and converging shape is there. Then in the starting, the HDB is same as like the journal bearing. Then metal to metal contact in the starting and ending, so friction is more and high surface hardness required. Then high load and high speed is there. Then HDB is used and applications are connecting rod and crankshaft. Then disadvantages is not applicable for the frequent starting is required. Then journal bearing, for that RF is near equal to R into mu. Then RF is equal to R into sin alpha. Then bearing characteristics curve. So you can see that BCN is equal to mu into NS upon P. This is very important equation. Then for static load, BCN is greater than 3 into K, and for dynamic load, BCN is greater than 15 into K. Then K is equal to bearing modulus, and epsilon is equal to eccentricity ratio. Epsilon is equal to E by E max is equal to E by C, and epsilon is equal to 1 minus H naught by C. Then C is equal to R minus R is equal to E plus H naught, where H naught is equal to minimum oil film thickness and capital R is equal to radius for the bearing and R is equal to radius for the shaft. Then the most important equation from the machine design portion in the bearing is Sommerfeld number. S is equal to R by C square into mu ns upon P. Here S is equal to clearance ratio square into BCN also. Then there is one more important topic is there, dynamic load carrying capacity, or you can say that the dynamic load rating. The equation for this term is L10 is equal to C by P raised to Q into 10 raised to 6 cycles, where Q is equal to 3 for ball bearing and Q is equal to 10 by 3 for the roller bearing. Then PE is equal to CS into X into V into FR plus Y into FA. Then L average is equal to L50 is equal to 5 into L10. Then at L10, R is equal to 90%. Reliability is equal to 90%. Then F is equal to 10%, and L10 is also equal to 60 into LH into N. Then rolling contact bearing is there. In that, dynamic load or fatigue load is applied and applications are in automobile or axle or gearbox. Then in the rolling process, rotate plus movement is there, and ball bearing is weaker than that of the cylindrical bearing or roller bearing. Now Petrov's equation, P is equal to W by 2 into R into L, where P is equal to bearing pressure and T is equal to F into W into R. Then P is equal to W by L into D, and F is equal to 2 pi square into R by C into mu ns by P, which is known as the Petrov's equation. Then loss of power is equal to F into W into R into 2 pi n by 60. Then Q is equal to HA delta T. From these two equations, there are so many times questions were asked. Then the limitation for the hydrostatic bearing is center of the shaft is at the center of the bearing. Then C is equal to R minus R, so no leakage is considered and applicable only for the less loads. Mackay's equation is there. F is equal to K plus 0.326 into R by C into mu n by P, and K is equal to leakage factor. value of k is equal to 0.002, t is equal to f into p and r, then t is equal to f into w into r into omega, then t is equal to f into p into u into r square. Then for axial thrust or thrust bearing, P is equal to F by A, so P is equal to F by pi by 4 into d2 square minus d1 square. Then for foot step bearing, T is equal to F into W into R, which is equal to F into Pn into R. So T is equal to 2 by 3 into pi into Pn into F into R cube, and power P is equal to T into W, which is equal to 2 by 3 into pi into P into Fr cube into W, where W is equal to 2 pi n by 60. You can say that the omega also.